Welcome to Summarize Science. Today, we're looking at a paper with a very provocative title, Microservices is Dying. For years, microservices have been the go-to solution for breaking down huge software systems into smaller, manageable parts, but the authors argue this has failed to stop the spread of complex dependencies between those parts. To solve this, they propose a completely new philosophy called the substance connection model, which is inspired by classical philosophy. Imagine each part of your software, or module, as a completely independent substance that exists on its own. These substances don't know or care about each other during development. They only form connections and start interacting at runtime when the application is actually running. This is a major shift from current methods, where connections and interfaces are hard-coded from the very beginning. How do they make this work without modules knowing about each other beforehand? The key is a set of similar concept interfaces, which are essentially universal interfaces. Think of it like a universal power adapter that lets you plug any device into any outlet. By having all modules conform to these standard interfaces, they can be connected in flexible ways after they've already been built. This isn't just a theory. The researchers built a platform called 8 to bring this idea to life. Using these universal interfaces, the 8 platform acts like a switchboard, connecting modules as needed. The most incredible feature is that it allows any part of a monolithic application to be dynamically loaded, unloaded, or modified at runtime. That means you can update or fix a piece of live software without ever needing to restart it. For example, if one module suddenly needs extra information from another, you don't have to rewrite and redeploy both modules. Instead, you can just add a small script to the linker that manages the connection, telling it how to handle the new request. This makes the whole system incredibly adaptable to change. The researchers put their 8 system to the test, comparing it against a traditional microservices setup for the same tasks. The results shown in this table are pretty staggering. 8 used dramatically less memory, around 120 megabytes compared to over 4 gigabytes for microservices in one test case. It was also significantly faster, with response times under 100 milliseconds, compared to nearly 500 milliseconds for the microservice. So let's recap the important takeaways from this research. The core argument is that true module independence comes from conceptual separation, not just physical separation. By designing modules as self-contained substances that use universal interfaces, developers can build their parts in complete isolation without needing to coordinate on specific details. This enables a highly dynamic system where parts can be swapped in and out on the fly, just like Lego bricks. What this could mean for the future is a new era of software development that is faster, more resilient, and far more flexible. It might even pave the way for AI systems to intelligently assemble and deploy software on demand.